so today we're going to be solving exponential equations. First one involves being able to get the bases to a common base. And we already kind of dealt with this before, but I'm just going to refresh your memory because it's been a little while since we've seen it. Got a couple examples involving this that involves modification of a bunch of stuff using some laws of exponents. So first off, let me refresh your memory that if we have anything to a power, we're going to multiply the powers together. That's a pretty typical step in these problems where that happens a lot. So make sure that we're considering that scenario when we're looking at this. And the first thing I'm looking at here when I start seeing x's up in the power level, so 8 to the 3x power, 4 to the 6x minus 1.5 power, I'm looking at the bases themselves and asking myself, can I make them into the same number? Something to a power or just, whatever. So looking at 4 and 8, can we all see that 2 to the second power is 4 and 2 to the third power is 8? Okay, so what I'm going to do, if I recognize the ability to modify these to the same base to a power, I want to write those things like this, 2 to the third power for 8. I'm going to put that in parentheses, raised to whatever power 8 was being raised to the 3x power in this case. And then I'm replacing 4 with 2 to the second power, so I'm going to put that in parentheses and raise it to the 6x minus 1.5 power. So I want to create this algebraic structure here to apply that algebraic rule. But again, if I'm modifying a base into something to a power, I want to make sure that entire expression is being raised to the outside power.
Sorry, how did you get 2? Did you divide by?
How did I get what?
2. 2 times 2 is 4.
Yeah, so 2 times 2 is 4, 2 times 2 times 2 is 8. So it's just a common, number that we've been working with quite a bit. Recognition of these things, like for example, 27 is 3 to the third power, 32 is 2 to the fifth power. So, kind of, if you did a factor tree even and found that it broke down to just the same number to a power, if you couldn't actually see it just outright, that'd be fine also. All right. So 8 and 4 can both be reduced down to 2 to a power, 2 to a power. And again, the key to this technique is these have to be, oops, supposed to be highlighted, these have to be the same number. If those can't be the same number, this won't be effective. So it's not worth doing if you can't make them into the same number. All right. Once we get them both 2 to a power, 2 to a power, now I'm going to use this rule which says I multiply whatever the inside times whatever the outside power is. In this case, so 2 stays 2. If I multiply the inside power 3 times the outside power 3x, I'm going to get 9x. For the other 2, I take the inside power 2 times the outside power 6x minus 1.5. This is a binomial, so 2 times both pieces. So 2 times 6x is 12x. 2 times negative 1.5 is minus 3. Okay, so again, power to a power, you take the inside times the outside power. Okay? According to this rule, whatever the base is stays the same. X stayed x, the powers multiplied. 2 stayed 2, the powers multiplied. 2 stayed 2, the powers multiplied. And when we get to the point where something to a power equals the exact same thing to a power, mathematically, the powers have to be the same number at this point. So I'm allowed to, since these 2's are the same number, to say that 9x must equal 12x minus 3. The only way for those two expressions to be equal to each other is if the powers are equal to each other. So that's a legal way to make the powers become non-powers. And then the remaining equation is just a basic algebra equation. Got a couple x's in a number. We're going to take the 12x, move it left. Negative 3x equals negative 3. Divide both sides by negative 3. That gets me x equals positive 1. As with all these problems, if I replace x with the number I got, it should create a true statement. And we can see that if I put x equals 1 in, I'm going to get 8 to the 3 times 1 is supposed to equal 4 to the 6 times 1 minus 1.5. This is 8 to the third power is supposed to equal 4. That's going to be 6 minus 1.5, 4.5 power. Obviously 8 to the third power is doable by hand, but I'd probably use a calculator since the numbers are getting a little large here. If I do 8 caret 3, it equals 512. If I do 4 caret 4.5, it equals 512. They are equal to each other, which verifies my answer of 1 is correct. So anytime you want to check your answers on these problems, it's an equation, replace x in the original equation to verify it actually works. This is not a necessary thing to do, but if you're unsure, that's how you check your answers. Again, this is the solution to the problem. If you want to stop there, you're welcome to stop there. But again, if you're unsure, if you want to verify that you're right, go back to the original problem, change x to the number you got to verify it actually works.